our previous episode, we looked at surds, the introduction of surds. We saw what a surd is and how to simplify a surd. Let us pick up from there. Let us remind ourselves of how to simplify a surd. Remember, we said that when simplifying a surd, we shall look for two factors of that number under the root, but one of them must be a square number. And then we shall replace that number by those two factors, and after separate them and get the square root of each. So we shall get the square root of the square number times the root of the second number. For instance, if we look at simplifying root 8, root 8 has two factors and one is a square number, that is 4 times 2. So instead of writing root 8, we shall write root 4 times 2 and then separate the two roots. So it becomes root 4 times root 2, and root 4 is 2, so we shall get 2 times root 2, which is 2 root 2. So meaning that root 8 is the same as 2 root 2. We have very many of them. You can think of any and try out on your own, because I do believe that perfection and improvement comes with practice. So you can think of any and try out, but basically that is the principle. So we can look at something else apart from simplifying surds. We can look at multiplication and division of surds. Yes, we can multiply surds. Just recently we have seen that to get root 8, you multiply root 4 times root 2. So that is multiplication, meaning that if I have two surds multiplying, I simply consider the numbers under the roots. For instance, if I have root A times root B, probably I'll get root of A times B, which gives me root AB. So that is how we shall multiply surds. However, sometimes those numbers under roots are the same. For instance, if we have root 2 times root 2, that probably gives us root 4, and we know root 4 is a 2. Then when we are dividing, for instance, if we have the numbers under the roots dividing, think of root of A over B. So we have a fraction under the root of A over B. So similarly, as we've seen with multiplication that we separate the roots, the same applies here. We shall square root the numerator separately and the denominator separately, meaning that root of A over B gives us root A over root B. That is how we shall divide. So we can take some of the examples of multiplication and division. We have examples which says simplify root A times root 2. Yes, when we are multiplying root 8 times root 2, that gives us root of 8 times 2, which is root 16, and root 16 is 4. Then with division, where we have root 12 over root 27, so we shall consider this separately. We get root 12, we simplify root 12 and also simplify root 27, since we know that 12 is 4 times 3, where 4 is a square number, and then we also have root 27, which is 9 times 3, where 9 is a square number. So you realize that they have a common root, which is root 3. Root 12 is 4 times 3, so that is root 4 times root 3. Then root 27 is also root 9 times root 3. So the root 3, since it is common, it will cancel, and then we shall remain with root 4 over 9. So since they are all square numbers, we end up getting 2 over 3. That is how we shall divide. Then, after looking at multiplication and division, we can look at addition and subtraction of surds. How do we add and how do we subtract? Yes, this is where it becomes interesting. Now, if you want to add or subtract surds, one, you must keep in mind that we only add or subtract surds if and only if the numbers under the roots are the same. For instance, if we have 3 root 2 minus 2 root 2, we shall get 1 root 2. So 3 root 2 minus 2 root 2 gives us root 2. But if we have 2 root 3 minus root 2, we cannot subtract those because the numbers under the roots are different. So we only add or subtract surds if the numbers under roots are the same. For instance, we are given our example 3 to simplify root 5 plus root 20, but they are not the same. However, we can simplify root 20 because we know that 20 is 4 times 5. So 20 gives us root 4 times root 5, but root 4 is 2. So meaning that from 20 we get 2 root 5, and therefore we can get root 5 plus 2 root 5 to give us 3 root 5. And now when adding still, you realize that we added these roots as any unknowns. For instance, it's the same way if you were adding x plus 2x to get 3x. So if we are adding root 5 plus 2 root 5, we get 3 root 5s. That's the logic. One, as you're adding, make sure the numbers under the roots are the same. Two, you add them as unknowns. We have the second example, which says root 54 plus root 150 minus root 24. Still, we shall first simplify these roots such that we come up with a common figure under the roots. And if you realize these three have something in common, we realize that 54 is 9 times 6, and 150 is also 25 times 6. Similarly, 24 is 4 times 6. So we shall come up with a common root, which is root 6. And after coming up with a common root, therefore we shall be able to add where we have to add and subtract where we have to subtract. So we shall end up with 3 root 6 plus 5 root 6 minus 2 root 6. So we first add the 3 and 5 to get 8 root 6 minus the 2 root 6, giving us 6 root 6. So as we are adding, we first make sure the numbers under the roots are the same. 2, we consider these roots as unknowns as we are adding or subtracting. Good. I wish you the best in your career.